I'm going to show you how to make distance time and speed time graphs to calculate the acceleration using a spreadsheet, which is a lot more civilized. There are better choices than a spreadsheet for science, but this is usually all that comes with most programs. So you go into Google Sheets and you open a new Google Sheet. And what we're going to do is we're going to fake some perfect distance time data. So the first thing you're going to do up here is write distance, and we'll call it meters. And I'll put time over here. Oops. Okay, let's call this time. And seconds, and my next column is going to be distance in meters. Underneath, let's make up some time values. 0, 1, 2. And I'll do this. Go down here, and every spreadsheet at some point is going to have an autofill. I'm going to try right-clicking. Nope, don't see it. Try clicking down there. I think, if I recall correctly, on Google Sheets, you go like this. There we go. Okay. I could teach you the right way first of all, but every spreadsheet does it slightly different. There is a way to autofill. So it took the pattern and filled it. Now for distances, what I would really like to do is square the numbers, because it turns out accelerated motion, these values here will be the square. So it should be 1 and 1, 4 goes to 16, 10 goes to 100. We can make that formula quite easily by putting in a formula here. I go equals, and if you notice, the time here is in column A2. So I'm going to just take the time value, A2, whatever is in column A2, and I'm going to multiply it by whatever is in column A2. And that will generate the square for me. You might go, you're not going to write a formula every one of those. No, I don't have to. Now I'm going to do this, click here, and bring it down. And there it goes. The formula is now in every one of those cells. See? Up here? Well, we entered the initial formula specifying square whatever you find in column A2. A2 times A2. When you pasted it all the way down, it updates the value. And so if you look at up here, you can see the number for the formula changing. So that's a great simple way of getting this here. So here's our distance time data. We're going to graph it. Google Sheets does one nifty thing that's new, is you can actually select the titles you've used as well, and it'll make sense out of those. So we go to Insert, Chart, and then you just drag yourself an area. Okay, I did that a bit crudely. There was a lag in the machine. So I undid it. I'll try again so you can see this clearly. Insert, Chart. And sometimes it'll pop up, other times you can graph it. Now look at this. Did it perfectly for me. It put the time on this axis and the distance on this one. Now, what if it does it in reverse? Then you go like this, right-click it, and you can go to Chart and Axis Titles. You can go to Axis, Horizontal Axis. Just play around in here, because every spreadsheet does it differently. So if I click horizontal axis, it's got stuff in here, and I'll go to setup. Oh, there we are. Look at x-axis and series. So if you got it backwards, you can edit and just change the numbers here, because sometimes it'll flip the graph. So you just simply have to locate your axis and series title. They don't call it XY. Now, there are other possibilities. It automatically picked this, but sometimes it might do that. And you go, what the heck is that? And this is where you're best off just playing with every spreadsheet till you figure out what it is you want. Well, in science, we're more likely to want it like that, and you put the drawing in later. So usually we want to see the data points, and then you'll curve fit according to that. The reason being, if I let it use this one, and we have real world data, and one of these distances instead of 36 was 72, and it's an error, it's going to do that. You don't want to see that on a chart, and that's why we would prefer that you do this. Let's see, let's just pick some axes again. Anything to bring up this chart editor. I'll go to setup, go to line chart, and I'll go down here to the scattergram. Now you can clearly see that that's a mistake. Some kid was not paying attention. So I'd prefer when we're using real world data that you not let it draw the line in for you because of that problem. But when the data is perfect like this one right now, okay, it's supposed to update that. It's not. Why not? So get used to the fact that every one of these things is different. And you just have to start moseying around to try to figure out why it's not updating. And so I try right clicking. I'm not seeing anything. Edit. Do I see a refresh? No. I'll try this. I'll try minimizing the window and then I'll open it up again. And maybe the chart will fix itself. I go, that's just, why is it not fixing itself? This is what happens with these things. So I'll try putting it in at 0. Nothing. Back to 36. What's going on here? Okay, so the only thing I can do now is try to drag a formula back into that spot. No. Try again. There's a formula. Pull it down. It's just not going to update that one. Oh, wait, there it did. It fixed it. Yay! I was too busy target fixating over here. So if you change a value, it can be a while. So there's our distance time graph. Boy, does she look beautiful. So let's smooth it down a little bit like this. I did it at the corner. Do not change it on the sides because you get that. And it looks like really stupid. So if you're going to scale it, always use a corner pip like this. Now, though, we want to compute the speed. So I'm going to switch over here and I'm going to do half time. And over here, I'm going to do speed. And we have to start calculating here. What is speed? Delta D over delta T. Okay, and I'm going to pause the video at this point, and then I will continue on with how to do the speed time graph when I have a bit more time. So do this.